Hello, this video is on the subject Instruments and Apparatus. This video will cover the material for the Instruments and Apparatus part of the West Virginia Mine Foreman test. The format for the video is question and answer. This video will also reference the question and answer to the West Virginia Office of Miners Health Safety and Training Mine Foreman Study Guide, and that will be in the 2019 edition. And these questions are in the Instruments and Apparatus part of the study guide. So the first apparatus we're going to talk about is the mine rescue apparatus and SCSRs. So here's a picture of the mine rescue apparatus. This is just a cutaway for a visual, but we do have some interesting things. We have compressed oxygen, so it's a closed circuit compressed oxygen device that's used in mine rescue. It does have a canister to put ice in it to cool the air, because the air I think is pretty hot, so it would be uncomfortable to wear unless you had that ice in it and the air flows over it to cool it. And also when you exhale 2.6 to 6.6% carbon dioxide, so there is a canister of some material that absorbs that carbon dioxide. So question 1, what is the Draeger BG4 mine rescue apparatus? And the answer, it is an approved, self-contained, closed-circuit, compressed oxygen breathing apparatus used in mine rescue operations. So the BG4 is a mine rescue apparatus. It's self-contained. It's a closed circuit, which basically means all the breathing you inhale and you exhale through this device. And it does have a compressed oxygen bottle. Question 2, how long would the Draeger BG4 mine rescue apparatus provide oxygen to the wearer? And the answer is 4 hours at moderately heavy work rate. So a mine rescue person is going to be, exploring ahead into areas that the atmosphere could be bad or probably will be bad, and they may have to be building stoppings back or something like that, trying to establish ventilation. They could be doing a lot of work, and so these are rated for 4 hours at moderately heavy work rates. Question 3, who is permitted to wear the mine rescue apparatus? And the answer is only people that are physically fit and certified in mine rescue equipment. So the person that wears this would certainly have to understand how the apparatus works, and they also have to be physically fit because it probably weighs about 25 pounds on a backpack. So imagine if you were carrying that, around in a mine, maybe in low coal, bent over or crawling. So you would have to be pretty physically fit just to handle this and carry it for a long period of time. Question 4, how shall mine rescue apparatus and equipment be maintained? And the answer is in a manner that will ensure readiness for immediate use. So, if we have a mine emergency that we need mine rescue teams, we need them. It's very urgent that they get in the mine and start exploring and maybe rescuing miners. So this equipment needs to be maintained so that it's ready as soon as you need it. Excuse me. Question 5, what is a self-contained self-rescuer? Or, I told you the answer, what is an SCSR? And that's approved self-contained self-rescuer. So that's what we always carry in the mine as a personal protective device for a bad atmosphere. SCSR, the initials stand for self-contained self-rescuer. Number 6, what's the purpose of a SCSR or self-contained self-rescuer? And the answer is to provide the wearer with oxygen in the event of a fire or explosion, or the atmosphere may contain hazardous or toxic gases. So if we have a fire or an explosion, if we have a compromised atmosphere where it could have hazardous or toxic gases, we would use the self-contained self-rescuer. Question 7, when should the SCSR be used? And the answer is immediately, the first indication of a fire or an explosion. So if you know that you've had a fire in your mine or have a fire, and if you know that you've had an explosion, then you should don the self-contained self-rescuer, because carbon monoxide is a very poisonous gas. It's colorless. odorless and tasteless, so you wouldn't know you was in it until maybe you started having some harmful effects from that. So immediately the first indication of a fire explosion, you should put your self-contained self-rescuer on. Number 8, how long would the SCSR provide oxygen to the wearer? And the answer is SCSRs are rated for 1 hour, and that's the requirement. They have to be rated for 1 hour. Cinco does make an M20, which is a smaller version, and it's rated for 10 minutes, but it's to wear on the section that if you had an emergency and needed to don a self-contained self-rescuer, the Cinco M20 would give you 10 minutes, which would hopefully allow you enough time to get to the cache of self-contained self-rescuers on your section. Question 9, how may the service life of the SCSR, how can it be extended? And that's by remaining calm and resting quietly. And I think what this means, if you have to don your self-contained self-rescuer to escape from the mine, you just ought to walk at a normal pace. You don't want to run, which would require you to use more oxygen. You just want to progress at a nice pace out of the mine. And you have rescuers stored at certain distances. So if you just take your time, don't get too excited. You'll have time to get to another cache of rescuers before the one you're wearing runs out. Question 10, what must be done if the SCSR is damaged, such as a puncture in the case or damage at the seal area? And the answer is the unit must be removed from service immediately. So if it's damaged, the seal's broke, you just have to remove it from service. Question 11, how can you determine if the SCSR is functional? And the answer is by checking the gauge or other indicators and looking at the overall condition of the SCSR every day. So every rescuer has a method of testing. Some of them have, I'm going to call it a fire extinguisher gauge. It's got a little round gauge. It's got a needle and, maybe in the green area, and that would indicate that it's good. Some rescuers have a little sight glass. It'll have a certain color, and, it'll tell you if it changes colors, it's not any good any longer. So you should check those daily and just check the overall condition of them. Question 12, what's the shelf life of the self-contained self-rescuer? And the answer is that which is recommended by the manufacturer. So the life of a rescuer will be recommended by the manufacturer, and they have a couple different lives. One life, if you carry them, they'll tell you it should last so long, and if you store them, that shelf life would be longer. The life of it would be longer if they're stored. 13, what effect does moisture have on the SCSR in storage? And the answer is moisture has no effect on the SCSR if the SCSR is sealed. So if they're sealed up, they're good. I mean, you obviously don't want to get them too wet, but if you have them stored somewhere and there's some condensation on them, they're getting a little bit wet from that, it won't hurt them as long as they're sealed. Question 14, what's the time frame for donning and activating the self-contained self-rescuer? The answer is approximately 30 seconds. And that may seem like it's a pretty short period of time, but you should be adequately trained to where you could probably get that on within 30 seconds, because if you would be in high levels of carbon monoxide, only a couple breaths of high levels could really present a problem for you. So you should, when you do have the SCSR training, you should take that very serious. You should try to learn how to get that thing on as quick as possible. Question 15, proper location of the SCSR in respect to the miner. And the answer is the SCSR should be within immediate reach at all times and in compliance with a cache storage plan. And that's what the regulations say. Somebody said, well, what's immediate reach? So after that question, it was determined that immediate reach is defined as no more than 3 feet from the individual. So the self-contained self-rescuer should be within 3 feet of you at all times when you're underground. Question 16, who is required to provide training to the miner in the use of an SCSR? And that's the mine operator. 17, how often shall underground employees be trained in the use of an SCSR? And the answer is that quarterly, with expectation training annually. So quarterly, once every 3 months, you're supposed to have some level of training with a self-contained self-rescuer. But every year you have to do the expectation training where you would be put into an environment that you would be able to see. It could be smoke, it could be a dark room, it could be you wearing glasses that you can't see out of. And you would actually supposed to don a training model. You should feel resistance and heat breathing through this. And you should also switch from one to another one. And you have to demonstrate, and you actually have to do that annually. Question 18, what's the general principle of the self-contained self-rescuer? And the answer is oxygen is supplied to the wearer and exhaled carbon dioxide is absorbed. So when you do exhale, you exhale 2.6 to 6.6% carbon dioxide, and it would be absorbed somewhere in this rescuer. 19, how do you breathe wearing the self-contained self-rescuer? And the answer is the wearer will inhale and exhale through the mouthpiece of the self-contained self-rescuer. Question 20, when it is essential to use the self-contained self-rescuer? And the answer is in an oxygen-depleted atmosphere, in an atmosphere containing toxic gases, and an atmosphere containing smoke. And essential means necessary or extremely important. So if you are in an atmosphere that contains toxic or poisonous gases, an atmosphere containing smoke, it's very important that you use the self-contained self-rescuer. 21, can self-contained self-rescuers be worn to fight fires? And the answer is no, they are used for escape only. Question 22, why are goggles provided with the self-contained self-rescuer? And the answer is to provide eye protection from smoke and harmful gases. Question 23, what determines the storage or shelf life of the self-contained self-rescuer? We've already had a question like this, but the answer is the storage or shelf life is determined by the manufacturer's recommendations. And again, that's probably going to be two different lengths of time. If you carry them, it's one length, and if you store them, it is another length of time. It will be longer if they're stored. They will last longer if they're stored. Okay, an anemometer is the next instrument we're going to talk about. And here's an anemometer. It's used to determine linear feet of air travel. So we need to determine the speed of the air or the length of air flowing down an entry. We usually take our air readings for 1 minute, but we always are concerned with the cubic feet per minute of airflow. So we can measure the width and the height of an entry. So now we need to determine how much air flows down the entry in 1 minute, and that's what we use the anemometer for. So here's a picture of a little picture I've made, and you can see my pointer now. You know, this gray box here where my pointer is going up and down is the anemometer, and air is flowing through it, and this arrow here indicates the air flowing through. And what we're measuring is the linear feet of air travel, or the length of air flowing through an anemometer. So if I stand in an entry and have my anemometer and I start it and I let it run, let's just say for 1 minute, and I stop it and my reading is 500. So what that means is the air that went through there in the first second now is 500 feet down the entry 1 minute later. So my air reading there would be 500 linear feet per minute. So that gives us 3 dimensions to calculate the cubic feet of air flowing down the entry. And that gives us the width and the height and the length. So question 1, what is an anemometer? And the answer is an instrument resembling a small desk fan that is used to measure the linear feet of air travel. Question 2, how are air velocities determined with an anemometer? And the answer is the linear feet of air traveling through an anemometer is recorded on the anemometer dials. So the velocity is just the the distance per time, and we always are looking for feet per minute. So the linear feet of air traveling, the air flowing through that, turns the blades on the anemometer and turns the dials, and that way we can determine the linear feet of air traveling, and we always do that for 1 minute, so we get linear feet per minute. Question 3, what's the length of time for taking air velocity reading? And that is 1 minute. Question 4, how are air velocities obtained with an anemometer? And the answer is by holding the anemometer in an air current and determining the linear feet of air passing through the anemometer for a given length of time. So we hold the anemometer in the air current, the air flowing through turns the blades on the anemometer, and that records on the dials the linear feet of air moving, and we always do that for 1 minute. Question 5, what's the quantity of air moving through an airway that is 12 feet wide and 5 feet high with an anemometer reading of 500 feet per minute? So we have 3 dimensions. We have the width and the height, and we have the length of air flowing down the entry. So we just multiply all those numbers together. The answer is 30,000 cubic feet per minute. It's the width times the height times the velocity of air. 12 times 5 times 500 is equal to 30,000. Number 6, what is CFM? And those initials stand for cubic feet per minute. Question 7, what should be done before taking air velocity reading? The answer is all the dials should be reset to 0. So before you take an air reading with an anemometer, you want to make sure that the previous reading is erased from it. So here's a little picture, and you can see I have this red arrow to this lever right here, if you can see my mouse. You just pull on that and it resets all the values to 0. So I start without a reading at 0, and then when I take the reading 1 minute later, it will tell me how much air has went through it. Question 8, how do you determine the cross-sectional area or just the area of an entry? And the answer is by multiplying the entry width by the entry height. So the area is equal width times the height. Question 9, what's the area of an entry that is 6 1/2 feet high and 20 feet wide? And the answer is at 130 square feet. So the area is the width times the height. The area is equal to 20 times 6.5, and that's equal to 130 square feet. Okay, a barometer. And a barometer measures the atmospheric pressure. The atmospheric pressure changes based on temperature, humidity, elevation. A lot of things affect the barometric pressure. But a barometer is a good tool to mine because it will warn you of decreased air pressure. And it can really have a big impact on seals. In gob areas, the air that could leak out. Seals could outgas with low barometric pressures. The barometric pressure really affects ventilation at a mine. And you'll notice that a lot more if you have seals and if you have a gassy mine and things like that. So a barometer is a pretty important tool to mine. A lot of companies have barometers and will write these readings down periodically so they can kind of keep track of that and what could be going on in the mine. Question 1, what is a barometer? And the answer is an instrument that is used to measure the pressure of the atmosphere. Question 2, 2 types of barometers. And the answer is a mercury barometer and an aneroid barometer. So I just have a couple pictures of them here. A mercury barometer is a tube that has mercury in it, has vacuum on the top, so atmospheric pressure lifts the mercury in the tube, and that's how we determine the atmospheric pressure. And the aneroid barometer is just a dial, and the needle would be facing on a watch would be 12, and as the pressure increases, it would go to the right, and as the atmospheric pressure decreases, it would go to the left. Question 3, what common varying conditions of mine air are determined by measuring devices, and that is the temperature, pressure, velocity, and humidity. Question 4, how does a mercury barometer work? And the answer is the atmospheric pressure is determined by the height to which a mercury column is raised in a vacuum. So I have a picture here with a lot of information on it. You can follow my mouse around, and we basically have a tube here, and we have mercury in it, and above the mercury is a vacuum. So there's no opposing force on top of the mercury. So the force involved is the force of the atmospheric pressure pushing up on this column of mercury. Mercury is very heavy. Specific gravity mercury is 13.6. So just to make a little bit of sense, a cubic foot of water weighs 62.4 pounds, and a cubic foot of mercury weighs 848 pounds. Imagine how heavy that is. So atmospheric pressure will push up on this very heavy material of mercury, and we'll push it up this column, and depending on the pressure, we'll lift it a certain height. And normal, we'll get this question later, but normal atmospheric pressure is 30. So that means that atmospheric pressure could lift this mercury column up this tube here for 30 inches. Question 5, how does an aneroid barometer work? And the answer is the atmospheric pressure is shown on the dial, which is measured in inches and tenths. And here we just have the dial. Standard or normal pressure is the needle, or the arrow would be 12 o'clock on a watch. And as the atmospheric pressure increases, it would go to the right. And as the atmospheric pressure decreases, it would go to the left. Question 6, what is the atmospheric pressure? And the answer is the amount of pressure exerted by a column of air above a given point. So here's the atmospheric pressure. So I have two objects here, a blue object, and you can see the length of the black line above it. So that's the atmospheric pressure being exerted upon this blue object. And here I have a red object, and you can see the amount of atmospheric pressure on it, which is less. The line is not as long, so you have less pressure there. But this is the atmospheric pressure measured at this point, the red point, and the blue point. So it's the pressure above a given point. Question 7, normal pressure of air at the Earth's surface at sea level. And the answer to that is 14 7/10 pounds per square inch. So at sea level, pressure at this point is 14.7 psi. Question 8, what's the barometer reading for normal air pressure at sea level? And the answer to that is 30 inches. So here's my barometers, my mercury barometer and my aneroid barometer, and both under normal conditions will read 30. And the barometer reading for normal air pressure at sea level is 30 inches. And it doesn't vary much. I mean, it will hardly ever go more than an inch each way. Anything less than 29 would be a pretty low air pressure. Anything more than 31 would be pretty high. So it's going to stay around 30. It won't deviate much. Question 9, the reading of a barometer is affected by elevation. How does elevation affect the reading of a barometer? And the answer is the reading varies with the way of the atmosphere. As we ascend or go up, the reading becomes less. As we descend or go down, the reading becomes more. So here's my picture again. So, this red object here has less atmospheric pressure than the blue object. And you can see the length of the line represents the atmospheric pressure. So this blue object is holding up this black line here. And the red object is also holding up the black line. So the red object doesn't have to hold up as much, so it's less. So you have less pressure on the red object than you do on the blue object. Question 10, what factors change the reading of a barometer? And the answer is changes in temperature, humidity, and elevation. So the hotter or the higher the temperature is of air, it would be less heavy. It wouldn't be as heavy. So if the temperature goes up, the atmospheric pressure will go down because you have less pressure. Humidity is a measure of the moisture of the air. So the higher the humidity, the more water is in the air, so that would make that higher. So the higher the humidity, the higher the atmospheric pressure will be in elevation, as we just described. As you go up in elevation, the barometric pressure becomes less. Question 11, what value is a barometer to mine ventilation? And this is a biggie. The answer is a falling barometer warns of decreased air pressure. So if you work at a gassy mine, if the barometric pressure goes down, your mine could just be more gassy that day because of a decrease in atmospheric pressure. It's really amazingly sensitive to what goes on in the mine based on the barometric pressure. Okay, the next object we're going to have is a water gauge, and a water gauge is used to determine differences in air pressure. So we have a water gauge on our fan, so we can tell the pressure difference that the fan is creating. We have to have a pressure difference to make airflow, and that's what the water gauge is going to do. So question 1, what's a water gauge? And the answer is instrument used to measure differences in air pressure. Question 2, describe a water gauge. And the answer is a U-shaped tube that is partially filled with water and is open on both ends. So here is a water gauge. It is U-shaped, and here on this water gauge we have a pressure on one side of it, or one leg. We have pressure on the other legs. We have P1 and P2. And on this water gauge, when P1 and P2 is equal, the water level will be the same. So this is just the same pressures on each side, the left and the right leg of this water gauge, so the water will be level. Question 3, how is a water gauge used to determine differences in air pressure? And the answer is to measure the difference. The ends of the tube are connected between the points which the difference is to be measured. So here, they're always hooked onto the fan, so you stick one end of the water gauge into the fan housing, and the other end of the water gauge is outside. So now we're measuring the difference of pressure between the outside atmosphere and the inside atmosphere. That pressure difference is what makes the airflow. Question 4, how is the ventilating pressure determined by a water gauge? And that's the answers by the difference in elevation of the water in the two water columns. So here's the water gauge, and we have, on this example, we'll just say P1 is outside of the mine, P2 is on the inside of the mine, and P1 and P2 are no longer equal. So P1 and P2 is not equal, so the difference in elevation of the two water columns is the ventilating pressure. So here, if you can see my mouse, this yellow area here is the difference in elevation of the two water columns, and that's the number that we're looking for. That is the ventilating pressure. Question 5, how is the water gauge graduated? And the answer is the pressure difference is measured in inches and tenths. So here's my little example. I have a little rule made here, and the increments is just in inches, and then that inch is divided up into 10 equal parts. So our typical water gauge reading could be 0.6, 1.2, whatever. That would be pretty low. A lot of mines will have higher than 2 inches of water gauge difference, but graduated in inches and tenths of an inch. Question 6, what pressure is denoted by each inch difference in the level of the water columns? And the answer to that is 5.2 pounds per square foot. So a cubic foot of water weighs 62.4 pounds. So each square foot, if you had a square foot, 12 by 12, and you had 1 inch of water in that, that would equal to 5.2 pounds. So 5.2 pounds per square foot. Question 7, where can total mine resistance to the air flowing through the mine be measured? And that's at the fan. So our pressure difference is basically a function of the resistance. So the bigger the water gauge reading is, the more resistance we have in the mine. As the mine gets bigger, we just have naturally more resistance to the airflow, so that is our water gauge reading would go up. Okay, the next instrument is a CSE digital 102 and 102 LD. These instruments are only used for measuring methane gas. You have to push a button to take a gas test. And these instruments are very good instruments. They've been around, I know, probably for 25 years that they've been making this CSE digital model 102 and 102 LD. I think they're just a standard go-to instrument for just checking methane. And here's a picture of them. The CSE 102 is on the left, and the CSE 102 LD is on the right, and the LD just indicates that it's a large display. And that's the only kind I've ever seen. I've never seen just the 102. The 102 LDs is what I'm familiar with. So you can put them on a probe and extend it out, 20 or 30 feet and still see your methane gas reading. So question 1, what's the first check to be performed on the CSE 102 methane detector before use? And the answer is just check for cleanliness and make sure there's no missing or damaged parts. You need to make sure it's in a permissible condition, make sure it's not damaged, make sure all the screws are in place, the seal or the gasket's there. You're going to take it in and by the last open crosscut, it needs to be permissible. Question 2, how is the battery voltage test performed on the CSE 102 detector? And the answer is by pressing both buttons on the instrument and ensure that the battery voltage reads between 3.5 and 4 volts. So here on this instrument, you push both buttons at the same time, and if it's properly charged, the display will read 3.5 to 4, somewhere in that range. A lot of them that I've used will read like 3.7. I don't think I've ever seen one to go to 4.0, but anything in between 3.5 to 4, if you would check the battery and it would read 3.5 to 4, then I think that instrument would be good enough for you to take underground. Question 3, how is the electrical zero test performed on the 102? And that is by pressing the test button only and ensuring the display reads either 0.0 or 0.1. So electrical zero means that it gives you the correct answer. So if you're out in your bathhouse at your mine and you have a CSE 102 and you press the test button, there's no methane there. So it should display either 0.0 or they will allow a 0.1 reading. So electrical zero is important. You're just on a test to make sure it's reporting the right answer, and outside there's no methane. So press the test button only and ensure the display reads 0.0 or 0.1. Question 4, how's a malfunction indicated on the CSE 102? And the answer is that is by a yellow light, and this will be displayed while performing the battery voltage test. So press both buttons at the same time to check the battery. If the instrument is okay and the battery is charged properly, the display will read between 3.5 and 4. If there's a malfunction with the instrument, a yellow light will appear. And you can see on the right-hand picture there of the 102, I have this big yellow, I'll show you with my mouse, this big yellow dot here, and obviously on the instrument that's going to be much smaller. I've just done this for instructional purposes, but a yellow light will come on. So when you do the battery voltage test, both buttons at the same time, if there's a malfunction with this instrument, this yellow light will come on. And I should say at this time, on the CSE 102 LD, the large display, the big face display, it does not have this yellow light. It will not display a malfunction. Question 5, how's a high concentration of methane indicated on the CSE 102? And the answer is a high concentration of methane indicated by a red light. This will be displayed while performing the test for methane. So here's another picture. You test for methane, you press the test button. If there's a high concentration of methane present, a red light will appear. And again, this is only for instructional purposes. You can see the big red dot. And someone told me a long time ago, and I don't even know if this is true, but someone told me that was 7%. So, Hopefully, if you use this, you'll never see the red light come on. Question 6, what button is to press when taking a methane test on the CSC 102? And that is the test button only. This instrument doesn't work unless you push the buttons. And to take a test, you push the test button. Question 7, what does the display consist of on the CSC 102? And the answer is the display consists of a high level of gas indicator, that's a red light, a malfunction indicator, it's a yellow light, and a 2-digit readout. Question 8, what checks should be made on the CSC 102 before using the detector? And the answer is before using the CSC 102, a visual inspection of the instrument should be made, the battery voltage test should be made, and the instrument should be checked for electrical zero. So before I use it, I'm going to just look at it, make sure it looks good, make sure it's permissible. I'm going to check the battery by pushing both buttons at the same time, and it should read 3.5 to 4. I'm going to push the test button only in fresh air and make sure it's electrical zeroed, and it should read 0.0 or 0.1. Question 9, how's a methane test performed on the CSC 102? And the answer is on the CSC 102, the methane test is performed by pressing the test button only. On the display, the whole number will be displayed on the left, and the tenths will be displayed on the right. So this measures to an accuracy of tenths. So here's the picture again. Press the test button and check for methane. The instrument will read to the accuracy of tenths. Question 10, how long should a CSC 102 be allowed to cool between gas tests? And the answer is the CSC 102 should be allowed to cool for 1 minute between gas tests. So here's a little picture of this. It's all these detectors work on a Wheatstone bridge principle. So I have a little arrow here. I have the electrical diagram of a Wheatstone bridge is shown here. And just use your imagination, but the red arrow here is pointing to this wire. So this wire's length will change because of the heat of the methane. So the amount the wire's length changes will indicate the reading of methane. So after you take a test, the wire must be allowed to cool to go back to its original length before you take another gas test. When we talk about that we actually burn an instrument up by putting in high levels of methane, the heat of that is so much that it literally burns this wire in two. So when we say we burn them up, we burn them up. So don't expose these to high levels of methane unless you can help it. Okay, the LTX 310 electronic detector, and this is an old instrument, and these questions and answers would apply to any instrument. Now here's a picture of it, and this instrument is probably not going to see this to the mind. I'm guessing, I'm trying to think, I think this is probably 20 years old at least, maybe 25 before this instrument would have been manufactured. It's still in the state study guide, and I think you can have a couple questions on that, but they're going to be generic questions that would apply to any instrument. So these questions are, number 1, how often must the LTX 310 electronic detector be calibrated? And the answer is that is every 30 days according to West Virginia state mining laws. So every instrument that we use at a mine to test for gas has to be calibrated every 30 days. I hate to say this because I don't want you to even hear this word, but I'm going to have to explain it. It is not monthly. Some people will say monthly. It is not monthly. It is every 30 days. So remember that, every 30 days. Question 2, what type of record must be maintained of the calibration of gas detecting devices? And the answer is a written record must be kept of methane detector calibration. The record of the calibration must be maintained by the operator. So we have to do it every 30 days. We have to keep a record of the calibration. The next instrument is an ITX multi-gas detector. And again, these questions applies to all instruments. Here's a picture of it. They can do different levels of gas. Some of them are 3 gas. I think some of them are 4. But again, these are generic questions that would apply to any instrument. So question 1, how does silica, compound vapors, or other known contaminants affect the combustible gas sensor on the ITX multi-gas detector? And the answer is the combustible gas reading will be lower than the actual gas concentration. So somebody says, well, what's silica compound vapors? And I've tried to research that and really can't come up with a good answer. But just imagine anything out of the ordinary that this detector would sense. Maybe even bolter glue, the resin glue that you use on a roof bolter. Maybe it could even, I'm going to just say, smell that, and it would adversely affect the readings. So the best thing, I just tell my students, if you see silica compound vapors or other known contaminants, you look for the word lower in the answer, and the combustible gas reading will be lower than the actual gas concentration, which is not good. You could have 5% methane and your instrument's telling you have 2%, which is still requires you to turn the power off and all that, but still, the reading that it's going to display will be lower than what's actually there. Question 2, how may sudden changes in the atmospheric pressure affect the ITX multi-gas detector? And the answer is it may cause temporary fluctuations in the oxygen reading. So the best example I can give of this, if you have a multi-gas detector with you, you ride your elevator out of your mind, it could alarm on oxygen because of the difference in atmospheric pressure. So sudden changes in atmospheric pressure will affect the oxygen readings. Okay, the next one is MSA Solaris multi-gas detector. Here's a picture. It's been a very popular instrument, a very good instrument. MSA no longer makes it. They've replaced it with an Altair. But the questions, I think there could be several questions on the test about the Solaris. And typically, most of them, you could make them 4 gas or 3 gas. Any 3 gas detector is going to do methane, oxygen, and carbon monoxide. So question 1, prior to each day's use, the MSA Solaris multi-gas detector should be checked for what and its calibration, check permissibility, and make sure it's been bump tested. Again, permissibility is a big thing. You want to make sure it's permissible because it's going to go in or in by the last open crosscut and make sure it's not been damaged. Calibration, make sure it's electrical zero. You haven't turned on. You're standing in the bathhouse. Methane should be 0%. Oxygen will read 20.8%. Carbon monoxide will be 0 parts per million. And also these are bump tested every day. There should be a little check mark on the display to indicate that it's been bump tested. Question 2, according to West Virginia state mining laws, the MSA Solaris multi-gas detector must be calibrated. And the answer to that is every 30 days or more often if needed. Question 3, when the low battery alarm sounds on the MSA Solaris multi-gas detector, how much operational time remains? And the answer is that's 15 minutes depending on the ambient temperature. And the ambient temperature is just the temperature of the air in the mine where you're at. Excuse me. Question 4, what happens when the batteries can no longer operate the MSA Solaris multi-gas detector? And the answer to that is the instrument will go into the battery shutdown mode. Question 5, if the MSA Solaris multi-gas detector is very hot or very cold, what must be done before charging? And the answer is the instrument must be allowed to stabilize for 1 hour at room temperature before attempting to charge. I used to have this problem. I had a Solaris that I would use in training classes, and it would be just in my truck. And I usually just left it in there, and I'd say, well, I need to charge my detector, so I would go get it. My truck may be cold, and it would never charge, and it has to stabilize at room temperature, normal what would be in your at the mine warehouse or bathhouse or in your house or whatever. But it does have to stabilize 1 hour at room temperature before you charge it. Number 6, when should the MSA Solaris multi-gas detector be when the electrical zero calibration is performed? And the answer to that is in fresh air. So when you perform this zero calibration, it's going to set itself to read 0% methane, 20.8% oxygen, and 0 parts per million carbon monoxide. So you need to be in an environment where you know that you have 0% methane, 20.8% oxygen, 0 parts per million carbon monoxide. So you always want to be in fresh air when doing the zero calibration. Question 7, when the MSA Solaris multi-gas detector is subjected to physical shock, what must be done? And the answer is that the calibration should be rechecked. And physical shock to me just means you drop it. If you drop it, bang it around for whatever reason, just recheck the calibration. Question 8, how do you determine how much charge is in the battery when the MSA Solaris multi-gas detector instrument is in use? And the answer is that it's the battery life indicator. As the battery charge dissipates, segments of the battery icon in the upper portion of the screen go blank until the outline of the icon remains. So here's a picture. I have this, here is a Solaris. You can see the battery, if you can see my pointer here. You know, it's totally blacked in. I have this arrow drawn out here, and I've just got a bigger version of that. But it does have like 4 boxes, and each one of them represents 25% of the charge. So here on the left, if it's 100% charge, all those boxes will be blackened in. As the charge goes down and now you're at 75%, just one of these boxes, the black disappears in it and you just see the outline of it. At 50% charge, you can see the 2 of them are blacked in, 2 of them are light. And at 25% charge, only 1 of them is blacked in now, and 3 of them are no color, just the outline. So that's just how you tell how much charge is left in it, and certainly you should start your day with it being 100% charged. Question 9, if the Solaris multi-gas detector detects that an enabled sensor is not properly installed, what happens? And that is the Solaris multi-gas detector will enter the sensor missing alarm, and the missing and sensor words will flash on the display. So it will be obvious to you. I've actually seen that before, and you'll quickly realize that there's something wrong. Question 10, what's the purpose of the peak reading on the MSA Solaris multi-gas detector? And the answer is that to show the highest level of gas recorded since turning the instrument on, or the peak reading was reset. So if maybe you're firebossing and you have an area, maybe it's a 20-foot high roof fall, and you have to check methane gas up in that area, so you put this Solaris on a probe and you extend it up to the top, and when you get it 12 inches from the top, it starts alarming, and you say, oh no, I have methane. So you pull this back down, and by the time you get it back in your hand, it is not in that environment any longer, and it's cleared itself back up. So you don't know how much methane you had above that fall. But all these instruments have the ability to check the peak reading. So with the Solaris, you would push a couple buttons, and it would tell you the peak reading. And after you record that, you could push another button, and it would reset it back to its normal reading or normal range. So the peak reading is a very good tool on these, and you need to be aware of the instrument that you use, how to check the peak readings. And it does say you can reset it manually, or every time you turn it off and turn it back on, it will reset the peaks or the minimum to their original or normal readings. The next instrument is the M40-M multi-gas monitor, and these questions again apply to all instruments. Here's a picture of it. It seemed like I've seen one of these a long time ago. It's a very old instrument as well, and I don't think many people use these. I don't think these were actually very good instruments. Question 1, what effect does oxygen-deficient atmosphere have on the combustible gas readings of the M40-M multi-gas monitor? And the answer to that is the combustible gas readings will be lower than the actual gas concentrations. So if oxygen is lower than normal oxygen is like 20.8. If it's lower than that, how is that going to affect your combustible gas readings? And they will be lower. So if oxygen goes down, your combustible gas readings will go down as well from what they actually are. Question 2, how may silica compound vapors or other known contaminants affect the combustible gas sensor on the M40-M multi-gas monitor? We've already had a question like this. When you see silica compound vapors, hopefully you remember that, you're looking for lower. So the answer is will cause the combustible gas reading will be lower than the actual gas concentration. Question 3, what effect does an oxygen-enriched atmosphere have on the combustible gas readings of the M40-M multi-gas monitor? So oxygen is higher than normal. So the answer is the combustible gas readings will be higher than the actual gas concentration. So if it asks this question with oxygen, if it's lower, your gas readings will be lower than what they actually are. If oxygen is higher than normal, your gas readings will be higher than what they actually are. Question 4, how do sudden changes in the atmospheric pressure affect the oxygen reading on the M40M multi-gas monitor? And the answer is it may cause temporary fluctuations in the oxygen readings. We've had a question like that before. I just think it's important, so I'll put it in here again. Changes in atmospheric pressure will cause your oxygen readings to fluctuate. That's the end of this video. Thank you.